In this video, we're going to discuss divisibility and the rules or cheats to see if a number is divisible by certain digits. So divisibility means the ability for a number to be divided by another number. So there are some different cheats that can help us determine if a certain number is divisible by some of the digits that we have off to the side over here. So we know that a number is divisible by 2 if the last digit in the number is an even number or 0. So if the number ends in 0, 2, 4, 6, 8, then we know that that number is going to be able to be divided by 2 and get a whole number answer. The divisibility rule for 3 is if you add up the digits within the number and that number is divisible by 3, then the entire number is divisible by 3. Let me show you an example. If I add up the sum of the digits, so 2 plus 7 is 9, then I know that 9 can be divided by 3, then 27 can also be divided by 3 and get a whole number answer. And that goes for as big of a number as possible. So if I even wrote the number 144, if I add up those digits, 1 plus 4 plus 4 is 9. I know 9 can be divided by 3 and get a whole number answer, which means 144 can be divided by 3 and get a whole number answer. The rule for being divisible by 4 is if the last two digits in the number are divisible by 4, then the entire number itself is divisible by 4. So it does not matter how long that number is ahead. So if we have a long number like 1,240, if we look at those last two digits, and if that number is divisible by 4, then it's divisible by 4, the entire number. So 40 is divisible by 4. I could divide 40 by 4 and get a whole number answer. So this 1,240 number is divisible by 4. I could divide this by 4 and get a whole number answer. For the number 5, pretty simple. If that last digit is a 0 or a 5, then automatically that number is going to be divided by or divisible by 5. For number 6, this one's a little bit interesting. If the number itself is divisible by both 2 and 3, then it's also divisible by 6. So for example, let me come up with, so if I have the number 48, I have to check if it's divisible by 2 and 3 to see if it's truly divisible by 6. So first, does it end in an even number? Yes, so it's divisible by 2. If the sum of the digits also are divisible by 3, so if I add those up, I would get 12. 12 is divisible by 3. I can divide 12 by 3 and get a whole number answer. Then that means this number is also divisible by 3. And since both 48 is divisible by 2 and 3, it is automatically divisible by 6 as well. I can divide 48 by 6 and get a whole number answer. For 8, if the last 3 digits are divisible by 8, then the number is divisible by 8. So again, as long as the number may be, only caring about the last 3 digits, if I divide that out by 8 and I get a whole number answer with no remainders, then that entire digit is divisible by 8. For 9, if the sum of the digits is divisible by 9, then the whole number is divisible by 9. So for example, if I have, let's do 8, 2. So 882, if I add those together, the sum of those digits gets me to 18. 18 is divisible by 9. I can divide 18 by 9 and get a whole number answer, which means 882 is also divisible by 9. I should be able to divide that by 9 and get a whole number answer. Lastly, the easiest one, A number is divisible by 10 always if that last digit ends in a 0. I know that this is a lot of rules to try and remember. That's why we're going to have this chart always available to you if we're asking you if a number is divisible. But it's really handy to know if numbers are divisible. 1, to know if a number is prime or composite. But 2, if you're ever dividing out a number and you are getting a remainder, it's nice to know if it's divisible or not, because that could be a way to self-check if you getting a remainder should happen or not. Let's practice our divisibility rules on the number 388. So we're going to check off all of the numbers that 388 is divisible by. So we just need to practice each rule with 388. So for number 2, if the last digit is even or 0, then it's divisible by 2. Since 388 ends in an 8 and that's an even number, I can check that 388 is divisible by 2. I don't even need to actually do the division. I know the rule. For 3, if the sum of the digits is divisible by 3, then the entire number is divisible by 3. So let's go ahead and add up. 3 plus 8 plus 8, that's 11, plus 8 is 19. 19 is not divisible by 3. I can't divide 19 by 3 and get a whole number answer. So 3 is not one of the options. 4, if the last 2 digits are divisible by 4, so I have 388, I'm only going to care about the 88. I'm not sure if 88 can be divided, so I'm just going to do a quick check. Quick division problem here. And then I can see that yes, I can divide 88 by 4 and not get a remainder, which means that 4 is, if 388 is divisible by 4. For 5, the last digit in 388 is not a 0 or a 5, so it is not divisible by 5. 6, I just have to check. If I have a check mark next to the 2 and 3, then yes, 388 would be divisible by 6. But since there's not a check next to the 3, I know automatically that 388 is not divisible by 6. 7, you probably noticed already, there's not a nice little trick for 7. So to see if 388 is divisible by 7, I actually have to do the hard work of dividing. So I just have to do a typical long division problem here to see if I can get a whole number answer without a remainder, and it's looking like, unfortunately, I get a remainder, which means I cannot divide 388 by 7 and get a whole number answer. Next, I'm going to check the 8 rule. If the last 3 digits are divisible by 8, unfortunately, 388 is a 3-digit number. So I just have to divide the whole thing by 8 and see if I can get a whole number answer. So again, just a normal long division problem to see if I can get a whole number answer. And unfortunately, again, I'm left with a remainder, which means 8 is not going to be one that I can check. For 9, if the sum of the digits are divisible by 9, so I'm going to add up 3 plus 8 plus 8 to get 19. I cannot divide 19 by 9, so that means that 9 is not a option. And lastly, since 388 does not end in a 0, 10 is also not going to be checked off. So 388 is only divisible by 2 and 4.